All right, so now what I've got for this one is I'm going to go ahead and just divide both sides by 6. And if I do that, I'm going to end up with this left side simplifying down to negative square root 2 over 2. And that's going to get me my sine that is equal to, our sine times x over 4. So in this case, I have to consider what is going on inside these parentheses here with this sine value. What is this x over 4 doing? If I was to graph that 4 is going to be changing my period of my sine function, but it's not going to be expanding it like the other one did. Instead, this is going to be, wow, I messed that one up. It's going to be expanding it instead of compressing it. So basically what I've got here is my sine graph that I've had. It's going to be going like this, but instead of going from 0 to 2 pi, I'm now quadrupling that. Everything is being multiplied by 4. So remember those critical values of 0, pi over 2, pi, 3 pi over 2, and 2 pi, all of those are being multiplied by 4. So then that means now that instead of being right here at pi over 2, I've multiplied that pi over 2 by 4, and now right here, this is going to be instead at 2 pi. Okay? So I've taken pi over 2, multiplied that by 4, and that's going to get me 2 pi. And now this one right here is going to be at 4 pi. And then here's going to be 6 pi. And then this one here is going to be 8 pi. So that's what that's going to end up doing. And so I'm looking at my graph here between 0 and 2 pi, and I want to know, when does sine equal negative square root 2 over 2? Well, between 0 and 2 pi, it's never going to equal negative square root 2 over 2 because my negative values for sine are all down here. And so between 0 and 2 pi, it's all positive right here. So this one would have none. It does not at any point in time equal negative square root 2 over 2. So I have no solutions within the domain that I'm looking at between 0 and 2 pi. Okay, so let's look at the work for the day. All right, so as this says, inequalities imply that regions of answers will be considered solutions instead of individual answers. It may be helpful for you to create a quick sketch of the trig function and compare it to the other side of the inequality. You may represent answers as compound inequalities or in interval form. I'm going to prefer interval form because it's easier, but either one of them is fine. So let's look at this. And the quick sketch, that's exactly what I'm doing up here. I'm just giving you kind of sketches of things, but I'm going to be a little bit more detailed down here with what I'm doing. So that's what we've got here. So here I've got tangent x is greater than 1. So let's look at that. And I also have to pay attention. This is between negative pi over 2 and pi over 2. Well, conveniently enough, that's what I taught you guys to do when you graphed tangent, isn't it? I said that if we're going to graph tangent, we're going to graph that between negative pi over 2 and pi over 2. And so if I did that, I've got my tangent function right here. I've got my asymptotes right here. And those right here would be at negative pi over 2, pi over 2. Okay? And I want to know, when is tangent going to be greater than 1? Okay? So what I've got to figure out here is, when is tangent equal to 1? Well, if I solve that, if I solve tangent x equals 1, that would be my arctan, and that's going to happen at pi over 4. And if I go around my unit circle, it also happens again at 5 pi over 4, right? Well, 5 pi over 4 is outside of that range. It's past pi over 2, so that's not going to be a possible solution. Negative pi over 2 to pi over 2 is my period for tangent. That's the period of pi right there. And so I'm only going to equal pi over 4 one time. And in fact, in this case, it's going to be right here. If you guys recall, that's where it equals 1 right here. Okay, so I have a solution of that happening once, but it's not asking me to solve it to find out when it equals that. That's just the starting point for my interval. So actually what I have here is at this point, at this pi over 4 and 1 right here, I need to know when tangent is greater than that. So it's going to be on this entire interval going up towards my asymptote. Once I hit the asymptote, well, actually, once I get near the asymptote, I'm never going to touch it, right? Then that's as far as I can go. So my inequality, the solution would be right here. It would be from pi over 4 to pi over 2 includes pi over 4, does not include pi over 2 because I can never equal pi over 2 when that's my asymptote. But I can be at pi over 4. That's where it equals 1, okay? So this would be your solution in this case. Let's look here. I've got tangent 2x is greater than or equal to the square root of 3. And again, I'm looking between negative pi over 2 and pi over 2. So it all seems great and grand, except for this whole 2 right here, which tells me that it's not just tangent x, it's a multiple angle. And so what I've done here is I've actually compressed my graph by 1/2. So what I have drawn over here for this tangent function here between negative pi over 2 and pi over 2, it's no longer going to do that. Instead, it's going to go from negative pi over 4 to pi over 4 here. And so then I'm also going to have negative pi over 2 and pi over 2 on the outside here. So if I do that, if I have my asymptotes right here, I thought I changed my color. Oh, well. If I do that, here's my tangent function. I changed my period to pi over 2. Remember, because tangent is pi over b, and in this case, b is 2. So I'm at pi over 2. So that's the length of my period. So if I go from pi over 4 and I go another pi over 2 farther, I'm going to be at 3 pi over 4, right? So this graph right over here is just going to be that bottom half, and this one right over here is going to be that top half, okay? So I'm going to go from negative pi over 2 to pi over 4, and it's just going to be that top half of the portion. So like from here up is essentially what it's going to do. And then from pi over 4 to pi over 2, I'm just doing that bottom half, okay? So now what I'm trying to figure out is my solution for this whole thing. So when I'm going to go ahead and solve this here, so I've got tangent 2x is greater than or equal to the square root of 3. So remember, in order to do this, I isolate my trig function, and then I can do my inverse. So it's isolated now, so I can go ahead and inverse this. So now I've got 2x is greater than or equal to inverse tangent of the square root of 3. Now remember, that's read, where does tangent equal square root 3? So now I have 2x is greater than or equal to, well, where is tangent equal to square root 3? And that's going to be at pi over 3. It also happens, if I'm going from 0 to 2 pi, it also happens here at 5 pi. Oops, sorry, nope, not 5, 4 pi. At 4 pi over 3. Okay? So I'd go ahead and I'd solve both of these and figure out what I have. And so now if I divide by 2 to both sides, that's the same thing as multiplying by 1/2. So if I multiply by 1/2, what do I have? So that's going to get me pi over 6. And over here, that's going to get me 4 pi over 6. which is going to reduce down to 2 pi over 3. Okay, now, is 2 pi over 3 less than pi over 2? Nope, it is not. So that can't be part of my solution. But I think you can agree with me with how I've got this drawn here. Tangent is going to equal that square root 3 twice. But if you notice, the other time it's going to equal square root 3, because it's in my positive section, it's going to be over here. So it's going to be between this negative pi over 4 and negative pi over 2. So what I need to do now instead is think about this. It's going to happen every single time in the same exact place on my graph. It just is going to be plus whatever my period is, k, each time. That's what that plus, pi over 2k is. And so that's what we have here. So instead, I'm going to have pi over 6 plus pi over 2k. And that's going to tell me every single time it's going to equal that value that I need, where it's going to equal square root 3. And so what I'm going to do here is, instead of plugging in 1, I'm going to try -1. So that would be pi over 6 minus pi over 2. Okay, so now if I do that, if I end up doing that, and remember, we got to get a common denominator when you're adding and subtracting. So then I have 1 minus 3. And so now I have -2 pi over 6, which that's going to reduce down and get me -pi over 3. And so that is what I have for the location that I've got right here. Okay, so I have two solutions. They're just located at pi over 6 and -pi over 3 to get me within the range that I keep saying range, within the domain that I need of -pi over 2 to pi over 2. So now I've got to write it as it's my interval. So I'm going to look, this is tangent 2x is greater than or equal to. So that means I'm going to be looking at these sections right here. So what I'm going to have here is going to be, from my interval notation, is it's going to be -pi over 3, and that's going to go to -pi over 4 because that's my asymptote, union, and then I'm going to pick back up again over here at this part right here, and that's going to be pi over 6 to pi over 4 because, again, that's my asymptote. So that's going to end up getting me my answer right there, okay? So again, from -pi over 3 to pi over 4 is going to be right here, and then pi over 6 to pi over 4 is going to be right here. Okay. All right. And I just noticed something. I thought about it when I was writing this over here. Notice, I wrote the answer wrong. This right here should have a parenthesis. Why should it have a parenthesis? Because my inequality is just greater than. It is not equals to. So it can't be the pi over 4, but it's everything to the right of pi over 4 and to the left of pi over 2. All right. I'm going to go ahead and I will do these next problems in another video.